Hi folks, this is Daniel from Hawkridge. Thank you for joining us today. We're going to take a look at what's included with SOLIDWORKS CAM Professional. So for today's webinar Wednesday, I'm going to start off by just kind of giving us an overview of what is SOLIDWORKS CAM. It's a new product launched this year, so a little bit about the actual standard version so you can kind of see what you would get from the professional package. Also, basically, how do I get it? So how do I get SOLIDWORKS CAM? How do I get SOLIDWORKS CAM Professional? And do you have posts for my equipment and things like that? So I've got a few slides here at the beginning that we're going to take a look at, and then I'll show you an actual example of how you can program some parts in SOLIDWORKS CAM, the types of operations that you can do, the types of benefits that going from the standard level up to the professional level will get you. So what is SOLIDWORKS CAM? Well, SOLIDWORKS CAM is actually an integrated 2.5 axis milling, 2-axis lathe program solution by SOLIDWORKS. It's actually been a product that was developed by CamWorks that we've been selling for quite a number of years now. That product was developed in '97, and it was the first gold partner for SOLIDWORKS in the CAM field. But essentially, SOLIDWORKS CAM uses some of the new emerging technologies, model-based definition, MBD. If you've attended any of our presentations, you might have heard the term MBD, model-based definition. Essentially, the principle is getting rid of your 2D drawings to put all of your 3D manufacturing, your PMI data into your 3D file, essentially. And how SOLIDWORKS CAM can leverage that information, access the tolerances, and use those tolerances to determine strategies on how to machine certain items. And also the knowledge-based machining, which is basically a way of saving your strategies, how you want to machine your parts, your features to a database so you can reuse them, so you don't have to reprogram things every time. And basically the premise is we're working right inside of SOLIDWORKS, so we've got access to our superior design tools. We've got our CAD side and we've got our CAM side right next to each other. We're not using archaic CAD sides in our CAM programs and things like that. So, and by using this integration, we can transform your design to manufacture process, improve communication between your design engineers and your manufacturing. Or if you've got someone that wants to do both, if you're an engineer that's looking at, hey, how do I go and produce parts? How do I actually cut them parts on the machine? What do these G codes mean? If you're getting into that process, SOLIDWORKS CAM will certainly help you get through that. Reduce errors, reduce cycle times using things like trochoidal milling. We'll take a look at what that means. And then also increasing your product quality. So reducing errors and reducing rework and things like that, running off old programs and legacy data and things like that. So how do I get SOLIDWORKS CAM? Well, essentially, if your subscription is up to date, then you will have access to CAM standard in 2018. So when you install 2018, so long as you're on maintenance with us, you'll get CAM standard in all of your packages. I'll go over what it actually includes in the standard version in just a second. The CAM Professional version is an optional add-on that can basically tie into that functionality and add extra products like turning and assembly features and things like that. So what's included in SOLIDWORKS CAM Standard? If you weren't watching the webinar last week that I think my colleague Lindsay presented on our 3D Solution Spotlight, she looked at the SOLIDWORKS CAM Standard. That's going to be available on our website if it's not available already to view. But essentially what it includes is feature recognition. So rather than having to chain edges together or select geometry and things like that, it will actually recognize the features based on the topology or the geometry in the model. And when it does that, it will actually look at how to machine it as well. So it'll look up in a database, how do you want to machine that particular feature? And then you can use that knowledge, save that knowledge into that database, and basically use a button to go and generate the operations for you. Now, SOLIDWORKS CAM Standard is a 2.5 axis milling. It has some 3-axis operations in it for area clearance, Z-level, and flat areas. but they're limited to parts only, so you're not able to produce assemblies and things like that. If you have equipment like routers, lasers, plasmas, water jets, that kind of equipment, and you do nesting, that's when you would have to go to the assembly level, really. It also includes tolerance-based machining. So that's going back to the model-based definition information that I just talked about. What that essentially does is it will look at the types of features that it finds, but it will also look at the tolerances applied using the MBD information and extract the tolerances and use those tolerances determining a machining strategy. So if you take a simple example of a hole might be drilled, it might be drilled and bored, it might be drilled, bored, and then reamed to get it straight. Those tolerances are essentially the practice that those machinists have to go through to determine how accurately that hole gets produced. The software is actually going to do that for you and work with you using the tolerance-based machining. It will automatically pick a boring strategy if you set a tolerance within a certain criteria that you set up. As far as the post processors go, there are a bunch of posts included for a range of machines that are in the default installation files of 2018. You can also go and create your own post processors using a tool called the Universal Post Generator. Now that tool is available for download from the CamWorks website, as essentially where CamWorks and SOLIDWORKS CAM will be developed together. And also it comes with a NC editor. So basically if you're using drip feeding to communicate to your machine, or you want to send the programs rather than using a USB key or anything like that, if you've got it wired up and you're sending code to the machine from your computers, basically there's an NC editor that allows you to do things like backplotting of the toolpath itself, so you can verify the G code that's coming out of your post. It will do the DNC setup to your equipment and a bunch of other functions as well. Things like edit capabilities, change sequence numbers, show you where the tool changes are, and things like that. And that's all included in the CAM standard version. What the professional level gets you is essentially the ability to program assemblies. So like I said, if you were working with a router or a plasma or a water jet or anything where you might need an assembly, things like if you're doing indexing with a horizontal and you've got a tombstone, we're going to look at an example of that a little bit later. But essentially, if you need to program in an assembly layout, you would need to get the professional package. The other thing that it adds is the ability to do indexing, pre-positioning, some people call it 3+2, for 4th and 5th axis machining. So a lot of times you'll be basically rotating your parts and keeping the brakes on the 4th and 5th axis locked, and just coming down and doing a drill hole or a pocket or a slot or something on there. The professional version will come with the indexing side, and again, we'll see an example of that a little bit later. The tricordial milling, or volley mill, is a term that's used for high-speed roughing. What that essentially does is it tries to minimize tool wear, reduce machining times for roughing cycles, and basically optimize your machine, your tool life, and produce parts quicker. The other things that the professional version will include are turning. So you'll get the turning module with the professional version, so you can program your lathe, and the ability also to use CAM configurations. So if you're working with parts from a mill and putting things to a lathe afterwards, or vice versa, or if you're wanting to do multiple programs in a particular file, then you'll get the ability to use the configurations in SOLIDWORKS CAM, not the standard SOLIDWORKS configurations that you get anyway. Last thing here, do you have a post for my equipment? There's 4 options essentially. Use the post applied. Go to the C drive, program data, SOLIDWORKS CAM 2018 posts, and there's a bunch of posts already in that location that you should be able to check out, see if they're going to work for your equipment. Always dry run them. Don't go in and just go flat out and start posting code and running on your machine without testing any of those posts first. Note that it's also the program data folder is a hidden file, so you will need to make sure your hidden files are shown on your screen. If you've got issues with that, just contact our tech support team. You can download the universal post generator, like I said, from camworks.com. You can also download a library post from our website. So on our main website, if you go up to products at the top, and you'll see CAM post processors, the link's actually in the screen there. You can download a bunch of library posts if you've got things like a Haas, a Mori, Herco, all sorts of different equipment there. That list will increase as time goes by, as we add more and more library posts to that list. If you don't see anything in any of those options that work for you, don't worry, we can also create custom posts for you to suit your equipment, to suit your needs and things like that. If there's any questions, just contact your account rep and they'll be able to put you in touch with us, and we'll be able to help you out. So with that, let's take a look at SOLIDWORKS CAM Professional. So I kind of wanted to start off just by taking a look at showing you what's included in the standard version, and then we'll take a look at what's included in the professional version. So essentially, we're working with the add-in here. We get our add-in for CAM 2018. It adds 3 extra tabs to our tree over here. This is where we can go and define our equipment. So if we've got a mill, a lathe, like I say, lathe is going to be the professional version. So the standard version include the milling side. But this is where we define our equipment, our tools that we're using. We select our post. If we're doing indexing, the positional side again, in this case, we'll just leave it set to none. So that's where we set up our machine information. Our stock controls basically our material that we're going to machine from. So we're just going to bump this up a little bit here in a few different directions. So we'll make it all symmetric. And it gives us an idea of the stock size down at the bottom here. And there's a few different ways of controlling that stock. I'm just using the bounding box, but I can equally draw a sketch, basically set that as a profile. I can use an STL file if I've maybe machined something from the lathe, bringing it into the mill. I can save out from the simulation side. I can save out an STL file and put it as the stock on the mill side. Or I can use a SOLIDWORKS part file or a configuration of a part file. If you're doing things like castings, forgings, you can use those as well for accessing more complicated stock shapes here. But I'm just going to use the bounding box for this particular example. And I'm a bit of a gearhead, so this is a brake caliper here, a bunch of different holes in it, some bores here for your brakes. And we're going to look at basically machining this. We've got some tapered walls here, some kind of little bit of 3-axis work in here as well. But essentially what the standard version gets me is the ability to hit this automatic feature recognition here, the extract machinable features, and it will go through and scan my model. And it's independent of the SOLIDWORKS history. If you're asking questions about, well, does it depend on the way I built my model? No. Essentially, it's looking at the finished shape of your model as it is right now, looking at the shapes of the topology of the geometry, basically, and trying to pick out features in my model to machine. People draw things in many different ways. Some people use extrude, some people use extruded cuts, some people use cavity features. Doesn't worry, doesn't matter. Imported files, if you're using things like parasolids, IGES files, step files, same thing. You'll basically recognize the geometry based on the physical shape of the model as it is right now. And then it'll also recognize strategies as well. So when it's looking at the feature recognition, it's finding multiple setups in here. So this would be as if I'm indexing or if I'm manually flipping it over on the machine, I'll be going through these different steps up here. But it's found a whole bunch of different types of features in here, slots, holes, some pockets here. It found some threaded holes. I'd use the hole wizard on the back here to create a couple of holes. Automatically triggers the thread cycle. That's just some of the power of the integration. That thread information in the hole wizard will actually pass over to your machining, pass all the tap data and everything else to go and machine that. If you thread mill, it also supports thread milling. But you'll see there's a strategy here where it says rough and finish. And this is basically a set of settings that are in my database that I can customize how I want to machine things. Pretty much a clear example of this might be, I've got these piston bores right here that I've got multiple steps in. So we've got a seal with a kind of an undercut groove in here. I've got a step and then basically another bore at the back here. Now, if I had to do this manually, I would have to go in and maybe put in a drill cycle, tell it the tool, tell it the settings, tell it if I want to peck drill it or just regular drill it, then go and put in a rough maybe to clear out a bunch of the material, then go out and drill it, interpolate it and try and finish the wall, and then maybe come in and bore it. The ability to save those settings to a database means I can just go, hey, I've got a strategy built for this. It's going to go and do that work for me. It's going to register all the cylinder diameters, profiles, and everything else, the start positions, depths. If they change from model to model, it will actually update these values as well. So it's not just it has to be this shape every single time. So I've got a cylinder bore strategy that I've just been in and customized here. Similarly, if I've got things like hydraulic fittings or something like that, where I've got a bit more complicated holes, there's actually a hole running all the way through here for passing the hydraulic fluid basically to these cylinders. There's a threaded section, we've got a chamfer on here. Essentially, it means I can just go and change a strategy in here to say, hey, I've got a bleed screw strategy that goes in and does all of that stuff. Just switch the parameters out here to a bleed screw. And then essentially all I have to do is hit generate operation plan, and it's going to look up in that database those settings that I've been working with previously and generate a series of operations for me. So I really clicked a few settings, but I've got an entire program that I can now generate the toolpath on and simulate that data. Another great thing about it, I can see the holder. I can see, hey, I've not actually roughed this material out yet. Maybe if I want to go in and 3-axis rough this profile first, I can do that. But it will warn me, or it will just give me a cut. I can control if it'll actually pause and say, hey, you're doing something silly, go and stop, tell me what's wrong with it, and then it will give me an idea of what I need to go and fix. Or I can just cut it and just watch my holder plunge straight into my material. So I can simulate that toolpath, see what's going on, verify it, and then go back and fix it. Now, if I wanted to add any existing features to it or add any existing geometry to it, it's just a case of finding the machining direction. In this case, my toolpath is coming from this top setup here, going in and telling it some 3-axis features. So in our 3-axis strategies, we've got a 3-axis area clearance, which is a rougher, a Z level, which is basically doing like a vertical slice, and a flat areas option. So I'm just going to go in and just basically rough this out here, do a Z level to kind of clean up this tapered section here with a big radius down at the bottom here. And then we just select our faces to machine, go and generate the operation plan. Again, I can save strategies to it for 3-axis. I want to do that rougher first, obviously, before I go and start machining the other geometry. So I can either just drag things to the top in here if I wanted to, or I can right click and sort the operations into an order that I want to do it. So if I've got a certain order that I want to basically program parts, maybe I want to face mill first, I want to then do my 3-axis roughers, then I want to do my 2.5-axis roughers, then I want to do my contour mills and my Z levels and stuff like that up here. I can basically control the order that I do these strategies. And then I can control, do I want the tool order adjusting? So I can do it either way. I can do it by tool first or by operation. If you hit apply, it goes through, adjusts the order of the program down in the tree here, adjust my tool order, and now I can go and generate that tool path in here to go and basically program the roughers to go and clear that out. And it's going a little deep for my tooling right now, so I can always go in and modify anything. We've got a full control over it. It's a full CAM package. It's not restricted anyway. If you've been using CAMWorks for many years, like I say, started in '97, essentially you've got the same controls as CAMWorks. You've got all the ability in here to go through and limit the depth of cuts, change the step downs and everything else in here. So if I only wanted to go up to say this position right here, simple change, I can go and change all my patterns in here to different types. Do I want to pocket in and so on and so forth. Basically go in and adjust my tooling, everything else. and we'll go and generate that toolpath there. We've got a ball nose in here that's coming in and basically cleaning up these walls down here. So we'll just let that generate here, and we'll take a look at the simulation once that's generated here. I should have a configuration where I've got, sorry, not this part right here. We'll just open this one right here. So I got a program, luckily I did this before, saved some stuff. I got a backup so we can always just take a quick look at it here. But essentially this allows me to go through, program essentially one particular version of it, and all of that was included in the standard version. If I wanted to go and change things like my strategies, and if I've gone and bought the professional version, maybe I want to look at doing some fancy tricordial milling. Maybe I want to go in here and start looking at roughing this out with a different strategy here. So maybe if I'm used to doing pocket in, pocket out, or some of this offset roughing, I want to maybe go and look at, well, how can I machine this part quicker? Essentially, time on the machine is money. I want to get this material out as fast as possible. There's a term in the industry called tricordial milling, and essentially what that allows you to do is you use smaller step overs, use the full flute on the tool. So in this case, I would go and say, look at my tool, look at my flute length, it's 1.5 inches. I would go and adjust my depth of cut to 1.5 inches. And basically what it's going to do is it's going to kind of do like an elliptical style toolpath as it loops around and comes back in here. What it will do is it will kind of adjust the feed rates as it's coming in here. So if we just take a quick look at the simulation here, you'll see it'll start on the outside and kind of do this kind of sweeping elliptical motion. Now what it's actually going to do is, as it's coming into the material line and it comes in on the opposite sides here, it's going to actually slow the feed rates down so you don't get that shock on the tool. If you've ever started a grinder or anything like that and gone into the material and it bites first thing, that's as basically you're taking a pot and taking a tool that's spinning at 4,000 RPM and basically going into static material. So it puts a huge amount of wear on the tool, going from essentially 0 to building up the speed. It slows the spindle down so you're not getting optimal cutting. It's basically why you use a lead-in feed rate, so you can slowly come into the pot and then start ramping up the geometry. But what this does is it automatically calculates it to adjust that feed rate as it's coming into the material, and then as it's coming out of the material, it will speed it up to get back to the other side again. One of the difficult things with new technology, like things like volume mill and things like this, is, well, what feed rates do I run these at? You've got the guys in the shop who might be experienced at using pocket in, pocket out, or certain roughing types, and certain tools and certain materials, but what feeds and speeds do I need to use this new technology at? Well, thanks to SOLIDWORKS and CAMWorks, there's actually a technology expert built right into the tool. So what this will actually allow me to do is I load up this technology expert. It recognizes the type of material that's set in my stock material over here. I can put in a hardness of that material if I've got a hardened coating, or if I've got a particular alloy or something of a version of it that I have a different hardness. It looks at the tool diameter that I'm using right now is my 5/8, number of flutes, what coating is on the tool, what type of holder, what are my machine maximums and things like this. And then it will give me a conservative to an aggressive amount. And it will adjust things like step over, depth of cut based on these values in here. Basically, I can adjust the feed rates and things like that, and basically go and use a wizard to try and get me some suggested feed rates in here. And then once I've closed that technology expert, it goes and updates this program and the program information based on the options that I just selected here. So I'd hit preview, and now I've got some high-speed milling toolpath that will go and clear this out as fast as possible, but also reduce the wear on my tool. We're not focusing the wear and the heat just on that bottom portion. we're distributing it across the full flute length, so we get better tool wear because we're not going straight into material and basically and causing wear on our tool. We actually get better machine life because we're not rattling those bearings as much in the spindle. So we actually get a much more effective, faster material removal in roughing here. And this is one of the options that SOLIDWORKS CAM Professional gets you, is this ability to go in and use these volume mill tool paths here. So with that, we've got a configuration here. We've got a configuration in SOLIDWORKS CAM. We've also got another configuration for the other half of this. So I've got one half here, but I've got a mount side as well of this. So I've got a side on the opposite side over here where it's got maybe a couple of extra counterball holes, maybe some slightly different types of features. Do I have to start and reprogram that again? No, of course not. SOLIDWORKS CAM Professional comes with the ability to have multiple configurations in your program, but those configurations also link to the SOLIDWORKS configurations. So if I was basically going to say, okay, I've switched over my SOLIDWORKS configuration to my other side where I've got these mounting holes in it, when I go and click on the CAMWORKS tabs, it gives me some options. In this case, I've already got one program in here, but essentially what it gives me the option is copy the existing program that I've already done. It's fairly similar to the actual other program, or I can just add a configuration and start from scratch. But in this case, I want to save some time. I'll copy and show that configuration, and it will do a rebuild and find any new features. It will remove old features if I wanted it to, but it will basically copy the program. So if you're using things like design tables or DriveWorks or anything like that, if you program your template, you're essentially using the same principles using your SOLIDWORKS rebuild to rebuild your CAM program. So it's now just going through copying all the information over to my other program, finding other holes in here, generating them, and basically I've got my program for my other half now, for my mount side and my outer side. So the CAM Professional gives me access to be able to use these CAM configurations, and I can use them in different ways. I can do it for keeping revisions of old programs if I want to always go back and basically keep an old program in there and I'm modifying it and tweaking it for trying to reduce cycle time and things like that. I can use it like that. Or I can use it for switching, if you've got the Professional, like I say, from switching between a lathe program to a mill program. If you've got a part where you've got both types of geometry in there, you can use it to switch between lathes and mills. Or I've got an example of the actual brake piston here where we've got a bunch of different SOLIDWORKS configurations in here using a design table. Well, do I need to go and program every single variant of those? No, I can basically just go through. In this case, I've set my machine up to a lathe. I obviously get lathe tools now. I get the access to a lathe post and a chuck and things like that. Stock is obviously now cylindrical. Most of the time you're putting in cylindrical stock into a lathe, but you can put in other types of geometry, other shapes, and other fixtures. If you want a fixture on the chuck to go and bore something, you can put fixtures on the chuck there as well. But the feature recognition works same sort of way, but in this case we're finding lathe features, facing, OD, groove, ID features, cutoff features, and things like that. And this is how quick it can be to program it. I've hit 3 buttons and I've got a program in here. The face rough is telling me, hey, you didn't add any material to the front face, so you can't cut any material that's left in here. So if I go and add maybe some material to the OD, some material to the end, and maybe put some material on the back here, do I want to go and update the toolpath? Sure. Yep, there's my lathe program that I can now simulate and go through. I've got my part programmed essentially. But we've got all of these other configurations in here. So maybe I've got a smaller one, maybe a 1.5D, which this is a 1.5 inch diameter, but it's a shorter one, maybe a 1.125 inch. As soon as I switch configurations, what do I want it to do? Copy and show? Sure. Click OK. It will do a rebuild. And this is the great thing about the integration. hey, you've got this feature, it found this one, do you want to sync them together? Yeah, I'll associate them. Replace any work together, these two, associate them, replace. Click OK. Now I've got my lathe program that I can just generate for this particular one, and I've got my toolpath updated for this particular part here for a shortened version. So I don't know of any other CAM program that can do things this quickly, which is some of the amazing things that SOLIDWORKS and CAMWorks have been doing for several years now. So we can use those configurations in multiple different ways. Again, the turning side is a professional version option. If we were to post this code out here, we would go and select our post, hit save, post it out, and I just fast forwarded through the code there, but then I can open it in my NC editor, and this is my SOLIDWORKS CAM NC editor. So if you're using your drip feeding or anything like that to your machine, I can click open, I can open the code, I can see what's going on, I can skip to the next tool change and things like that. I can readjust the sequence numbers. I can also do things like backplotting as well. So if I want to backplot this with a certain type of equipment, maybe I'm doing, say, FNUC turning, backplot window, what do I want to see? Do I want to see the G code? And this is actually running off of the XYZ coordinates in here, XZ coordinates in this case for the lathe. But essentially, you can open up a mill part here. This is one that I exported earlier for a mill program. Like I say, go to different tool change positions, look at the code, readjust the sequence numbers, and again, do things like backplot the code. And obviously, in this case, I wouldn't want to do it with the turning profile. I'd want to do it with the milling package, but you would get the idea. And then you go to your transmission, set up your DNC, and then hit send, and you would get your control basically ready to go and load the program. So this is included in the standard version and the professional version with the CAM editor here. But a couple of other things that we talked about being included here. We talked about indexing, 4th and 5th axis, and also assembly machining. So I've got an example here of a tombstone assembly where we've got that same brake caliper basically on 4 sides of a tombstone. So if we're using like a horizontal mill, or if this is maybe it'd be a big machine, but a 4th axis rotary in here, we're rotating parts around on our mill, on our vertical mill. SOLIDWORKS CAM will actually support the indexing or pre-positioning, or 3+2 people call it, for 4th and 5th axis rotations in the professional version. The other thing this is it's a SOLIDWORKS assembly. So if I've got things like here, I've got a vise, if I've got fixtures, if I've got a bunch of parts laid out into a sheet where I'm going to nest it, I could use the Nesting Works tool that we offer, go and create a SOLIDWORKS assembly, and then I would use my SOLIDWORKS CAM Professional package to go and program that assembly. And what we get in here is the ability to go and select the different parts in here, so it knows which parts are ones to machine and which parts are fixtures. So I just hit add all in there. We get now 4 pieces of stock because we're on a tombstone. Essentially, you've got 4 sides of it here, different sides facing different orientations. And we can go and hit the feature recognition, and it would go and basically find the features in the different orientations and things like that. But maybe we've already done some prototype work, or maybe prototype something on the 3-axis mill, but then we want to go and use the 4th axis horizontal because it's just become available. It's just finished doing a whole bunch of parts. It's available. We build an assembly. Rather than having to reprogram it again like I would be doing here, I can actually just go through and say, hey, actually get rid of this stuff. I don't need to redo that stuff again. We're going to set it up to do some indexing here. So I'm going to define my coordinate system is basically going to be rotating about my y-axis in this case, because it's a horizontal up here. I'm going to set up my rotary axis to be, 4th axis here. Rotary axis is going to be our y. But I'm going to get rid of this stuff down at the bottom. I don't want that stuff down here. This is stuff that I've just created using the extract machinable features. I've got a program that's already in my part file. Why can't I leverage that? So if we're going from like a prototype to a production level, like we are maybe with this particular part here, we want to try and get a finished part off of this basically on every cycle. I can just import the program into my assembly here, and then I just need to generate the toolpath, make sure it's avoiding things like fixtures and everything else. And I can go and set my fixtures up. Obviously, there may be some reordering, readjusting of the operations to suit the horizontal and the fourth axis here. But essentially, we've got this part where we can actually control the indexing and get the rotations out to the code itself. And I will see those rotations. And this is a huge program. There's basically 4 of those parts for all the programs going in for all the different setups here on the machine. So it's taking a little bit of time here to calculate, but I don't have to reprogram this thing from scratch, which is the beauty. So once we've kind of adjusted the order in here, I've just gone through and created a version of it, basically with the order, with that sort operations, sorting out face milling, sorting out the toolpath here. Basically, I've got some toolpath over here. I've got some toolpath over here. It's going to index or rotate this to basically see what's going on here. I've just added my fixtures in here as well, so I can actually see the vices. I can see the tombstone. I can see the parts with all the stock in here. And you'll see what we mean by essentially doing the indexing of the pre-positioning here. So it's basically machining one side. It's going to rotate around once it's finished this side. So once it hits those flats down here, it rotates the assembly. I've got my machining going on the other side here. So there's my first face operation, and we can control the order of everything and the order that the toolpath goes in here. But essentially, it's running through my entire program here to go and get that part off the machine, almost finished basically. So you can see the material updating during the simulation here. And with that, that's really the end of the presentation. I've got a few more slides here just to cover let me just switch it over here. Some other information here. We've got some more up and coming webinars. The thermal load analysis and some information about SOLIDWORKS simulation on next Wednesday, on the 25th. We've also got some others which are coming up on Composer, Visualize, and Inspection in MBT, the model-based definition I talked about on Friday, October 20th, and then another one on the 27th, which is looking at what's new in simulation as well. And if you've not captured or been to visit one of our rollout presentations for the new 2018, a few of them are closing up this week, so or just check out the one that we recorded and put it on the website there. But if there's any questions at all about what the capabilities are, you can always contact our support team. This presentation has been recorded, so it will go up on the events page as well.